So I'm going to start with the 45s. Okay? So when you look at a 45-degree angle here, and I'm just going to use the first quadrant to start with. If my radius on a unit circle was what? 1. And then the pattern for my 45, 45, 90 is x, x, x root 2, correct? We should have done that last year. Right? And the shortcut pattern for finding what the length of each leg is on an isosceles right triangle is you take the given hypotenuse, divide by 2, multiply by root 2. Okay? So what is 1 divided by 2 times root 2? You get the coordinate root 2 over 2, right? So there's your x coordinate. It's also your y coordinate because they are the exact same. So what we can do right here, if you either memorize this set of numbers, root 2 over 2, that's it. You just have to memorize that. That's the set of coordinates for the 45s. Okay, what you can do is you can now find the cosine of 45, which is root 2 over 2. You can find the sine of 45, which is root 2 over 2. And you can find the tangent of 45, which is 1. Yeah, root 2 over 2 divided by root 2 over 2, which is 1. Okay. Now, yeah, Jack. So, if you can use Pythagorean Theorem, but hopefully in your geometry class you guys went through and figured out what the pattern was for 45, 45, 90. And since the pattern is x, x, x root 2, what you could do is you could say that you know that x root 2 in this has to equal 1. So if you solve for x, the length of each leg, your answer is 1 over root 2. But if you rationalize that, you get root 2 over 2. But rather than go through that step, that process all the time, the shortcut is just take the hypotenuse, divide by 2, multiply by root 2, and that's the length of each leg. Okay, so you get your values there. Okay, now, what this allows you to do, and even when you guys are filling this out on Friday, what I would do is whatever pattern you have, you should go through. You could do all the quadrantal angles first because those should be easy to find. Okay, and then I would do all the 45 degrees. Okay, and the reason for that is, and we'll talk more about reference angles, but reference angles in a unit circle are going to help you with trig ratios. Because if you look at this 45 and you draw a line horizontal or parallel to the x-axis from C, it's going to intersect what point over here? G. Okay, and so because these are parallel, what does that mean the y-coordinate of G is going to equal? It's the same y-coordinate, right? Root 2 over 2. And because this is still a 45, 45, 90 triangle, when we drew that here, this x here corresponds to this x, but it's not in the positive direction. Instead, it's a mirror image, so it's going to be a coordinate of what? Yeah, negative root 2 over 2. Okay, when you come down here, you can find the coordinates of this point are going to be an x of negative root 2 over 2. They have the same x. The y is the same y, but it's mirror image, so it's going to be negative root 2 over 2. And then when you move back over here, or if you continue this piece down, you can find the x-coordinate here is going to be what? Root 2 over 2, and the y-coordinate, now it's going to be negative. So you can use the fact that these angles are going to be mirrored across the quadrants, okay, on this unit circle. But by doing this, we can go back now and we can find here the cosine of, and what was this angle at G? (135). The sine of 135 and the tangent of 135. And we can find those because the cosine is the x, negative root 2 over 2. The sine is the y, positive root 2 over 2. And the tangent is going to be what? Now it's a negative 2 root 2, or the 2 root 2, or root 2 over 2 divided by negative root 2 over 2. Same values, but opposite signs, so it's going to be negative 1. At 225, the cosine was negative 2 root 2, or root 2 over 2. The sine was also negative root 2 over 2. And the tangent, two values exactly the same. The negatives cancel out, so it's a positive 1. Okay, and at 315, we have a root 2 over 2 for the cosine or x value, I guess. A negative root 2 over 2 for the sine, the y value. And then the tangent is the ratio of those when you divide, which is also going to be negative 1. Okay. So any questions about finding those? Okay, so we found all of these. Okay, we already established the quadrantal angles. All right. So let's take a look at then the 30 degrees. So when you're filling out your unit circles, I would, if you're going to start with 30 degrees, that's fine, but either choose. You start with 30 degrees or the 45s, okay, and just I would do all of them. Okay. But then I'd go to, let's say, the 30 degrees. So if I start with my first 30 degree, which is this one right here, again, the hypotenuse is 1. When you have a 30, 60, 90, the pattern of information that you use for this is you have the leg opposite 30 degrees is x, the side opposite or the leg opposite 60 degrees is x root 3, and the hypotenuse is 2x. Okay, so that's your general pattern for 30, 60, 90. So that means if our hypotenuse is 1, the easiest piece to find is the one that's opposite 30 degrees, because that's going to be exactly half the hypotenuse. And what was the hypotenuse? 1. So the half of that is 1/2. So this height right here in this particular case, or the y coordinate, is going to be 1/2. Okay, and then the other leg is going to be the length of this side, which we said it was 1/2 times root 3. So 1/2 times root 3 is root 3 over 2. Okay. And so that's the other piece that you need to memorize. Or if you want to memorize things and not recreate it like I did just here, okay, you can memorize that the shorter side is 1/2, the longer side is root 3 over 2 for all the multiples of 30. Okay, so when you're finding here the cosine of 30 degrees, it's going to be root 3 over 2. The sine of 30 degrees is going to be 1/2. And the tangent of 30 degrees is sine over cosine. And if you divide those out, it's equivalent to multiplying by the reciprocal. The 2's cancel. 1 over root 3 rationalized is root 3 over 3. Okay, so again, I wouldn't spend any time trying to memorize that the tangent of 30 degrees is root 3 over 3. I would simply recreate it in this first quadrant, do the math right here, invert, multiply, okay, and then you know what your pattern is. Once you find the pattern, what you can then do is you can find all the matching pieces along the unit circle. So notice all the pieces that are mirror images along the x or the y. And then you can figure out those. So here this is 30 degrees up from 180, so this is 150. So I have the cosine of 150, the sine of 150, and the tan of 150. And if I wanted to find those, the cosines are the x-coordinates, so they map together. This is the negative of here, so we have negative root 3 over 2. The sines are exactly the same, so we have 1/2. And then the tangents are going to be the same ratios, but again, for a tangent, sine over cosine is going to be the same numbers, just the signs might change. Since one sine's positive and one sine's negative, the tangent's going to be negative as well. So negative root 3 over 3 would be your answer. Right, so the cosines have the same x's as this, so negative root 3 over 2. The sines are exact opposites, so minus 1/2. Since I'm dividing by two negatives, I know my tangent's going to be positive, so root 3 over 3, but it's going to be the positive of that. When I move to quadrant 4, my cosine's going to be the same as up here, a positive root 3 over 2. The sine's going to be the same, but in the negative direction, so minus 1/2. The tangent is a negative divided by a positive, so it's going to be a negative, but the value will be the same, root 3 over 3. So now I found all the multiples, or all the matching pieces, the mapped on pieces of my 30 degrees. My final one is to find the 60 degrees. And so when I look at my 60-degree triangle that's formed in that first quadrant, it's the same as it was for the 30, 60, 90, except it switches the x and the y, right? So my coordinates are no longer root 3 over 2 and 1/2, but now they're 1/2 and root 3 over 2. So again, if you have to memorize anything, there's only 3 things you need to. Root 2 over 2, that's for the 45s. And then root 3 over 2 and 1/2, those are for the 30s. Okay? And you just need to be able to figure out that which one is the shorter side, or the shorter leg, and which one's the longer. And then you can identify the same things, cosine, sine, and tangent. Okay, so the cosine is the x-coordinate, 1/2. The sine is the y-coordinate, root 3 over 2. And now the tangent, you do have to do another calculation. Okay, it's sine over cosine. In this case, we have root 3 over 2 divided by 1/2, which is like multiplying by the reciprocal. Those cancel. And so my tangent is going to be the square root of 3. Okay, and when I find the pieces that map on here, that are reflections, I can go through, and for these remaining pieces or angles of 120, 240, and 300, I can find what the other trig ratios are by just matching their corresponding pieces and assigning the correct sign, positives or negatives. So I want you to do that for those remaining angles, please. All right. So let me fill in these last ones, and then I'll answer that question. All right, so as you're looking through here really quickly, cosine of 120, it's the same cosine value, but it's in the opposite direction, so minus 1/2. We map here, it's the exact same y, so root 3 over 2, so the signs are the same. The tangents are the same, but again, it's a negative and a positive, so we have to change the sign, negative root 3. Come down here to quadrant 3 at angle 240. The x's here are exactly the same, so minus 1/2. The y's are exact opposites, so minus root 3 over 2. And then the tangents are the same value, but check the sign. A negative divided by a negative gives you a positive, so positive root 3. And then finally in quadrant 4 with the angle 300, you have a same exact x, so 1/2. The opposite y's here, or you can use the same y's over here, negative root 3 over 2. And then the same tangents, but again, a negative divided by a positive gives you a overall negative. And so that's